So we are recording now, and I'm going to share my screen with you guys so we can go take a look and see what kind of mess I got going for you here. Okay. This thing's, the problem with Zoom on my screen, I use a laptop to see you guys. And the screen's so small that whenever I have when I'm sharing the screen with you and that, I can't see anything underneath, okay? I think this was last week's, right? And there were a few of you that had a little problem. Don't worry about it. Just get it in. My plan will be to check these later today, maybe. If I have the time. I do have an afternoon class too, though. But I'll probably start either today or tomorrow, you know. If you don't have them in yet, what do? You email Doug and tell me when you get it in so that I can go back and grade it, right? So we should be, I think, good on that stuff. That's what we went over the other day. Am I in the right? I think I'm in the right one. Yeah. So then I opened up number 2, which is this one here. And we are going to program the cylinder program in class today. Okay. So that'll be an introduction to some like variables. So after today, you can use variables. And we're going to talk about that a little bit. One thing I'm going to tell you here, okay, so you're going to want to make a note of this. And this doesn't just pertain to this program. Can you guys see this, by the way? Hello?
Yeah, we can see the blackboard.
Yeah.
We see it.
Somebody nod their head by saying, yeah, we can see it, Doug.
Okay.
Jeez. I swear I'm going to put it where everybody has to have a video camera so I can see that you're not asleep. On this one, okay, couple things. First of all, this is how we spell Celsius. Celsius does not have 2 C's. Every semester, every class, bar none, I always get somebody, even after I tell everybody this, that's going to misspell the word Celsius and going to lose point. Likewise with Fahrenheit, it's spelled like this. Now, when you use them for variables, they can be lowercase. In other words, it can start with a lowercase because that's the convention for variables, that they start with a lowercase letter, not an uppercase. But Celsius and Fahrenheit are proper nouns. So when you put your output out, okay, for the user, you want to use the proper capitalization, okay? So that's the first 2 things. Spell the words right and use them properly. In the program itself, they'll be lowercase, but when you display them on your screen, the first letter should be uppercase, like all proper case nouns. Second, when you're doing the math for Celsius and Fahrenheit, you have to either divide 5 by 9 or divide 9 by 5. Okay? So if you type in 5 divided by 9, just like that, you're gonna, or let's do 9 divided by 5. The answer you're gonna get is 1. And that is wrong, okay? Because 9 divided by 5 is actually 1.8. But if you type in integers with no decimal places, Java assumes that you're doing integer division. And integer division only returns the integer part of the word, okay, or of the number. So again, big difference, right? Believe me, if you had a temperature, a human temperature, and you converted it from Celsius to Fahrenheit, and you used 1 versus 1.8, you're dead. You guys still hear me? Hello?
Yeah.
All right.
Kind of low.
Kind of
Yeah,
low.
you sound distanced.
Hello. Here, is that any better?
I think you might have to adjust the mic.
Oh, give me a break. Hang on. Microphone here. I don't touch speakers and microphone. Audio settings. Here we go. Well, my mic's almost all the way up here. Test. I don't know.
That's better.
I think I have it maxed out right now. Is that any better?
Is it the
Yeah.
output level volume?
I've got it all the way turned up. My mic.
Yeah, no, it definitely sounds better.
All right. Okay. So you need to put a decimal point in. So you can either do 9.5 divided by 5 or 9 divided by 5.0, or you can just do 9.0 divided by 5.0. As long as one of the numbers is a float or a double, then the math will do it with a fraction. If all you want is the integer portion, then you leave them as integers. But in this case, you do not want to do that. Everybody understand the 3 things we got here. We're going to spell the words right, Celsius and Fahrenheit. You're going to use them in lowercase to be variables if they're a variable name you use. And that the division you're going to use is at least has to have 1 decimal point. So that's the hint on that one. Cost of driving is pretty simple. You're going to have how many miles driven from the user, how many miles per gallon of gas your car gets. So miles, MPG, I'll accept as a good variable name. And then price per gallon, okay? Just price is fine there. And that should give you, so you take the miles driven divided by the MPG, gives you how many gallons you need, times how much the gas costs a gallon, and that should give you the total cost of the trip. Okay? So that's that one. 2, we're going to do in class, ethics of programming. This is just a simple thing that these people came up with, the Association of Computing Engineers and Machinery. Just things you should know if you're going to be a programmer. Okay? So that's lesson 2, okay? I'm not going to go on to lesson 3. We'll talk about that when we get done here, see if we can get a program in today. So I am going to go ahead now and start NetBeans. And again, if you have questions, you need to speak up because I can't read your minds. I can't see your faces to see if you're totally bewildered. But believe me, if you have a question or are mixed up in some way, then there's probably somebody else in the class that's also in that, has that scenario going, okay? So let's get rid of this one that I did. And so we're going to start a new project. Again, it's Java with Ant, Java application. We hit next. We come over here, make sure these 2 checkboxes are checked. Make sure we're saving to the location we're saving or that we want to save to. Now, if somebody was having trouble with their iDrive popping up all the time yesterday, I don't know what's going on with that. Hopefully they got that rectified. But I'm just going to call this cylinder. And again, it only has 1 L. cylinder volume. Let's make it that. Okay. And I'm going to go ahead and notice how I made that capital C, capital V for the name. The names of my program should be in upper, just like this. Okay. I call that book title capitalization. No spaces. So the first thing again we do is we document what we're doing. So our internal documentations go here. So this will be the Acme cylinder volume calculator. And this is the name of the file there. You see it, it's cylindervolume.java. So cylindervolume.java. And again, the reason we put that there because later on our programs might have multiple files that we need to run them. Today's date is already 2/16/2021. I'm ready for this month to be over. Author. I'm such an optimistic person if you haven't figured that out by now. My wife says, you're such a pessimist. Okay, not really though. I have faith. Okay, the purpose is a program to calculate the area and volume of a cylinder given a user's input of radius and height. Okay. So first thing we need to know, how do we get data into our program? Well, we use something called a scanner. And the scanner is not built into the program, so we have to go get it. And where do we get it from? We get it from a library. And we want to import a Java utility. So it's util dot, and then this box will pop up. Those are all the things we can import out of the utility bin. And so I want a scanner, and mine's going to probably lock up. I don't know why, because I have a fast computer, but it always does this, and it's going to come up as abstract collection, which I don't want. I want a scanner, semicolon. Okay, and this is similar to a blueprint. We can, the word is instantiate an object from. In other words, we can create an instance of a scanner in our program. We don't want to, it's like a blueprint. We don't want to have to write a program where we have to write the code to get code into our program or to get data into our program, because that would be a lot more code. So somebody's already written it for us, and we can use that by importing it. Later on in your programming, you'll be able to create objects that you can bring into your program. So that's what we got up there. So now we have to, all that does is get me to the blueprint. Okay, now I have to create it. It's like building a house. I got the blueprint, now I can build the house. So I want to build a scanner. And I'm going to call, the scanner has to have a name. I'm going to call it user con for user console. And notice how I made that variable. It starts with a lowercase letter. Any subsequent words are uppercase. I call that camel hump. Okay. And then I want a new one of these scanners that comes from the system in device. And in our case, what is the system in device? Anybody know? System in device would be, how do we get stuff in? What are we going to use to put data in? Hello?
I mean, our computer or our PC, but
But what part of our computer are we going to put in data with?
Terminal.
Yeah, our keyboard, right?
yeah.
Yeah, so your system in device is your keyboard. What do you think your system out device is? Because we use that to print all the time. What's your system out device?
Um,
Where do you see the data once you run it?
Monitor.
The monitor. That's your system out device. So here we are instantiating a scanner named usercon. Okay. Now, most of our programs are going to be divided into 3 parts. Okay. The first part we need inputs. Okay. Our program probably isn't going to do anything unless we put something into it. So the first thing I need to have is my inputs. Well, before I get my input from my users, we want this to be programmer friendly, I want it programmer friendly, but I want it user friendly too. So if all it comes up and says enter a number, that isn't good because they don't even know what they're doing. Okay, we have to tell them. So we're going to tell them this to begin with. We're going to say that this is the Acme cylinder volume calculator. So we're giving them a little banner that kind of gives them a hint as to what they're doing. Okay. So I use this for user friendliness. Next thing I'm going to do is I'm going to give them a prompt. And prompts should be meaningful. Notice I'm only using print here. And I'll explain that in a minute, not print line. So here I'm going to say enter the radius of your cylinder. Then I put a colon there, a space, so it looks pretty. If I use print line, after this line prints, it goes down to the next line. If all I use is print, the cursor stays on the same line. Now, this is a matter of preference. Do I want the user to put their data in after the prompt to the right of it? Or do I want them to enter it below? If you want them to enter it below, you use print line. If you wanted to, my preference is to put it on the right after the entry or the prompt. So I don't put in a new line. And then I'm going to make a variable here. And my variable, what do you think the name of my radius should be? What data type? What data type do you want for your radius?
An integer?
Okay, what's the problem with an integer? Not that you're wrong, but what's the problem with it? What can I put in an integer?
It's just numbers, right?
Just numbers, that's all we're putting in, yeah. So if I'm going to build a patio out behind my house, will it always be an integer in size? It will if we use integer.
Yeah, I'm just a little confused on what you're asking. Like, I understand, like, I don't know why we wouldn't use integer, is what I'm saying.
Okay. What if you want to put it right behind your house, and when you measure your house is 30 feet and 6 inches wide? What's the problem with an integer? Can you make your patio 30 feet 6 inches with an integer?
Can you not use decimals with an integer?
Not with an integer, you can't. It only takes whole numbers.
Oh,
So now that you've thought of that, what should I be using? I'm going to have to start calling on you guys by name because nobody wants to answer except Ray here. I think this is Ray talking. So Ray, which one you going to pick
I'm a bit
instead of it?
confused too.
What?
Just I'm a bit confused too.
yeah, I forget the other
Okay.
types of things we can use,
Well,
but one
you-
obviously that accepts decimals is
Yes,
the answer,
you're
but
right.
I just can't think of it.
Well, you need to memorize those. I said that I'm going to allow you guys to use integers and doubles. You don't have to worry about float or short or long. So if it's a whole number, for most cases, it'll be an integer. But if it's not a whole number, in other words, if it's float, we call it floating point. That's the geek term. Okay. So if you measure your measurement and you get 10 feet 5 inches or 6 inches, you cannot put that in, or 10.5 feet, I should say. You can't put that in an integer. It won't allow you to do that. You'll get an error. So you'd have to pick a double. And I'm just going to call this radius. And then what am I going to put in there? Well, I'm going to say user con, and then I want the next double to go in there, just like that. And if you noticed, when I typed in my scanner name and hit dot, it asked me a bunch of questions here, or these are different functions of things I can get. I can get bytes, floats, integers, long, shorts, okay, et cetera, et cetera. But since I'm going to go with the double, just makes it easier. So it's next double. And we read these from right, in programming, we read from right to left. So in this one, for example, we're creating a scanner from the system. It's going to be new. We're going to name it usercon, and it's going to be of the type scanner. Down here, I'm going to get the next double in my scanner called usercon, and it's going to be assigned to a variable called radius. That's a double. Okay. So that's how, so we have a nice prompt. And so we have another nice prompt here. Again, see, I put a little space there so that when when the user types in, he's not typing right up against the prompt there. And how about our height? What data type is that going to be? Tricia? Tricia, what data type?
Oh. Can you guys hear me?
Yeah.
Okay. I was trying to adjust my headset. I'm not sure because I'm confused.
Okay, well, we had a measurement before for radius. We're going to do it in whatever measurement, a linear measurement. And we said that it's not necessarily going to be a whole number. So we had to pick a floating point data type, and we picked double. So this is a height. We're not sure how thick it's going to be. So what do you think this one should be if it's not a whole number? I'm giving you hints here on the screen.
Double?
Yep. and we'll just call it height. And then user con dot next double. Okay, so that's our inputs. We needed 2 inputs from the user to calculate the area and the height or the thickness of our concrete or whatever, or cylinder or whatever it is. Okay, again, the data types that you can use are any of the ones that are allowed by Java. All I'm telling you is I will let you get away with using the integers and doubles. You use the integers if it's a whole number, you use the doubles if it's floating point. I'm not going to worry too much about some of the other ones that are more economical. In other words, there's one called short, and that's for smaller integers. There's one called long. Now, if you're going to calculate something that's a whole number that's over 2 billion, integer won't hold it. So if you wanted to do like the population of China, you would have to go with a long, because you can't put, these are like a mailbox. This is memory, right? This is how much memory I'm going to reserve to store my number. And this one for double is really, really big. Okay. You're talking grains of sand in the ocean. You're talking, this is accurate to about 15 to 17 decimal places, but it can hold a number with like 300 decimal places. Okay. Where a float, which is a little bit smaller, is only accurate to about 7 decimal places. But I'm going to allow you to use the bigger one so you don't run into any problems. All right, but you need to memorize those. And again, you got a string. String holds anything that we don't do math with. We have Boolean, which can only hold true or false. We have char, which can only hold 1 character. Okay. So they're all different sizes, and you have to know them. And this is in every language that I teach. Okay. Oops, I don't want output yet. We haven't processed anything.
Hey, could you, I just like, I'm following so far, but I am a little confused on what the function of like the scanner is exactly. You said it was like we imported it, but what does it do?
It's
Exactly.
going to allow you to get data from the keyboard into your program.
So it's just like picking up like what, like the variables we're making?
Whatever
right?
they type, okay, it's going to take that and try and store it right here. When the user types something, it's going to take that right here
Yeah.
and try and store it in this variable.
All right, cool. That makes sense.
Okay.
Yeah.
And that's what it does for you.
Awesome.
You just don't have to program it except to create it. Okay. All right. So once I have those 2 numbers, excuse me, I need the formula for the area of a circle. So the area is equal to pi times the radius squared, right? Except you can't do that in Java. You need to change to Java math. Okay, so we need the area, but since Java does not allow exponents per se, there's no, other languages do, but Java doesn't. So we have to actually put in, we can do 1 of 2 things. We can say, first of all, what is our area going to be? What data type do you think? What was it? DAIJ, Daj. Do you know?
What was the question?
What data type are we going to use for the variable to hold our area? Well, we can eliminate some. Is it going to be a Boolean? Is it going to be true or false?
I think it would be. I don't think it would be a Boolean, would it?
Nope. So it's not a Boolean. Is it something we're not going to do math with?
Um,
Is it part of a math equation area?
I think we would do math with it, wouldn't we?
Right. We will do math with it. So it can't be a string. Okay. Might it have fractions?
I don't think it would have fractions.
Oh, well, of course it would. If you take 3.23 times 9.5, you don't think you're going to get a fraction?
Oh, no. Oh, I'm sorry. I thought you were like still like going with exponents.
Well, I'm dealing with what we're going to store those in. Okay. Once we do the math. So something that would hold something that's going to let me have a fraction. What data type is it?
Would it be a float?
Could be a float, yes. But we're going to stick with double. Same thing, okay? They both hold floating point, just floats hold smaller ones. Okay, so we're going to say double area is equal to, now, what are we going to do about pi? Pi is 3.14159 for our purposes. So I need to create something that will hold that number, okay? So I'm going to type something called final, and it's definitely a double. And variables or constants instead of variables are all in uppercase. So I'm going to type pi in uppercase is equal to 3.14159 for our purposes. Okay. Now, nothing in that makes it a constant except the word right here, final. That means it cannot change because a constant is a named place in memory to store data that will not change during program execution. So for all of our purposes, this is the number we're going to use for pi. The capital PI is just for programmer friendliness. If a programmer sees something in all uppercase, they know that it's a constant, that it's declared somewhere. Okay. Now, if I wouldn't know that, there's also this. Okay. Well, we'll just use it. I'm just going to say this pi, and then I can do times, and we got something called radius. And radius squared is nothing more than radius times radius. Okay. Now, that being said, if I had more, let's say I had radius to the 10th power, am I going to type radius times radius times radius times radius times radius times radius? No, I'm not. There is a function that's built in called power. Okay, so I could do math.pow, and then I could say radius, and it's to the second power. So I go delete, delete, and I type a 2 there. And that would mean the same thing. Okay. So there is this math library that's built in that has some stuff in it that's available to you. Now, for my purposes today, I'm going to cut this out of here and just leave it radius, radius. Because unless it gets to be more than 2, this is what I usually do. But I'll put it over here so you can remember it. Those are the same thing. They don't mean any different than that. Okay. So now, as we're building this program, we don't know if what we did so far is working, and we need to test that. And I probably should have tested up here to make sure I was getting what I wanted from radius and height. You don't want to write your whole program and then run it and say, uh-oh, doesn't work. You should be testing it as you add things, as you go, to make sure. It's a lot easier to fix it then than it is once you get, especially a big program. You're not going to write some huge program, several thousand lines, and never test it as you go. So we probably should have tested our radius and height up here to make sure we were getting what we wanted. But for now, since I didn't, I'm going to go ahead here and just make sure everything's working till this point. So what do I have so far? I have a radius, and then I can put a space in here. And then I have a height. And then I'll put another space in. And then I have the area. Okay. So I'm going to test and make sure that I at least can get the area. So now when I run my program, by the way, it automatically saves. If you're typing along and think, uh-oh, I better not lose this, you can always click the two and we don't even, they're supposed to be floppy disks if anybody still knows what those are. So I click it and that saves my program up to where I'm at. And then I click run the program. And it should pop up here. And there you go. It says enter the radius. I'm going to put in 10 because then I know the radius times the radius will be 100. And if I multiply that by pi, the area should be somewhere around 314. The height ain't going to matter yet. But you can see there I get the height, the radius was 10, the height was 10. And so far the area, which is pi times the radius squared, should be around 314, I told you. And we get 314,159, which is exactly right. So we know up to this point that our program is working correctly. Anybody following along that has this in and it isn't running?
Yeah, so when it asks me to enter the radius of my cylinder, but it doesn't have like a colon, so it doesn't look like it actually is accepting a value. So like so it says enter radius, and I could do space. I do 10, and then it says enter height, which actually has a colon, so it looks like it wants me to enter a value. I put 10
Okay.
and then it gives me one long 10 point huge.
Well, because you don't have spaces in between these. I put spaces in between this if you're printing it out.
Let me see. Oh, let me see.
Now you should get 3 numbers. And these colons are just literals, right? I just put those in because I think it looks cool. They
Oh, I
don't
see.
do anything. Everything that's brown on my screen doesn't do anything. Okay,
It's
except
just
the
a prompt to show up for people.
Exactly.
Okay, that makes sense.
The gray, of course, doesn't do a thing. It don't show up. All it is notes. Okay. All has to do with programmer friendliness. And if I wasn't teaching you guys things like this note, I wouldn't put in, because anybody that knows how to program in Java knows what the scanner is. I'm putting some of this stuff in just so you guys understand what I'm doing. Okay. And
Yeah.
hopefully it's helping some. So now, did you get a nice little printout there?
Yeah, I did. I didn't realize that.
that I put spaces in here.
Yeah.
Yeah.
Which it makes sense
Okay.
now.
So I can leave that in, or I can remark it out by doing that, put my 2 slashes in front of it, and now it just becomes a comment. So if I wanted to keep it, I could. There's no real reason that you need it in your program, though, once you've tested it. So you can just delete that, okay? So I got another process yet I still need to do. I haven't figured out my volume. So by now, Madison, what kind of data type do I need for my volume?
Would it be another double?
Be another double, yep. And all I need to do, since I already have the area, I can just say area times height, right? Because the formula of volume is just get the area and then how deep is it or how tall is it, right? So that should give me my volume. And that's all the processing I need. And again, when we talk about programs, most programs have inputs, processes, and outputs. In other words, we get data and we convert it to information. My output is information, my input is data, and somewhere in the middle, I have to process that for human consumption. Okay? So now we're going to output it. So what do we want to output? I'm going to say system.out.println, and I'm going to say, okay, so the cylinder, or wait, here, let's do this. A cylinder having a radius of, and I got a space there after the of, and then I'm just going to put in here radius, and then space has an, let's see here, has an area of, and then we can kind of do this. Okay, so I just went here and put colon and then space and the quotes, and then I hit enter, and the computer automatically added this line down here. And it's area of area. Square units.
Hey, so my thing's doing this, my NetBeans is where my cursor is, like where I want to type as this black bar that's just beating.
Okay, so that means you probably have your overtype on. If you go on your keyboard and on the top of the top line next to print screen and delete, there's one that says insert. Okay,
Awesome.
press on that and it'll turn it back into a thin line.
Okay, thank you. I must accidentally hit it.
Okay, so there's my area it's going to print out. So I need basically the same thing. So remember when I told you up here we had system in to get it from the keyboard? Now we have system out. So that means send it to the monitor, right? I don't know what I want to do with this here. Let's see. And get rid of that. And a height of height of oh, come on. Volume. Okay, so again, it starts out, it's just reading. This is plain text. And then we come here and give them the number, and it puts the number there. Then it continues on, puts in a number there, and finish it like that. Same thing here. Starts off, prints out that, then it prints a number, then it prints all this, puts another number in, da 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 da. So let's see what this mess looks like when I run it. And again, we know the area. If I say the area or the radius is 10, so that means it's again 10 times 10 is 100 times 3.14. So it should be about 314, something like that. And then if the height is 10, then it should be about 3,000 and something. So let's see what happens. Okay. So a cylinder having a radius of 10 has an area of 314.14 or 59 square units. That's right. And a cylinder having a radius of 10, I'm missing a space right there, and I got too many spaces here. A height of 10 will have a volume of 3,141. That's correct. I know those numbers are correct because I can do them in my head. But I am missing a space down here. A cylinder radius of right here, I think it is. No, that ain't it. Where's it at? Oh, right here. After the number, I need a space. And then if I have a space here, I don't need one here. So now if I run it and do my 10 and 10 again, that looks much better, okay? Cylinder having a radius of 10, 314, that's right, a cylinder having a radius of 10 and a height of 10. I still got an extra one in there, right in front of the A height. Okay. That's weird. I'm getting a little extra room there for some reason, but it's good enough. In other words, you could have typed these all on one line. I just didn't want to run them out to the right. So I just continued them on the next line by adding this plus sign. Okay. Same thing up here. I could move this. If I just did this, that's no different. I just didn't want to run it out. And same thing here. If I wanted to, I could have done this. And ran it out. Okay. So that looks good. We have this header up here. We have nice prompts. We do our process. We have an output. When we're all done, we're going to do something that isn't required normally, but if you do this, it makes it nice to the user. They know everything is all done. And you can make up the name of your own company. I just use the Roadrunner Wile E. Coyote scenario. So I got that. So that's for user friendliness. Then I come down here, and after the last, notice my indentation. This one I can look straight down and see its matching one. Here, I can see the matching one up here. There's nothing in between them to stop me to make sure that they have a matching one. So then I'm going to come down here, put in a comment for the programmer or any other programmers that might look at this. It just says no code follows. So they're not looking farther down the page for any additional code. I save that. Okay. And run it one final time to make sure there's no problems. And this time, maybe I'll make it, let's test it for like fractions. We can say 10.5. And let's say the height is 3 foot 7.5 or 7.5. And you can see that it works fine. I start getting some big fractions, and I'll show you how to deal with them later on. But it works fine. It doesn't crash. Now, can I make it crash? Well, right now I can. Until you're in class for about 4 weeks here, this will be what will happen. Right now, our program isn't user friendly in that if I do this, and by some reason I type in the letter X, the program crashes because I can't store a letter in a double. Okay. It won't let me. Okay. It can't be, if I type in a number, it's fine. But again, if I type in a punctuation or a punctuation mark, program crashes because it can't store that. Okay. So right now, later on in your programming, I'm going to show you how to prevent them, the user, from being silly. In other words, enter a radius for your cylinder should be pretty self-explanatory. Enter the height for your cylinder should be pretty self-explanatory. Okay. But if they don't do that at this point, you can't prevent them from not doing it, from crashing the program. If you get something from me in the future that says your program abends, A-B-E-N-D, that means I could make it abnormally end. And having an abnormal ending is not good. In other words, every time you run your program, you should get this if it's running right. Okay. And there should be nothing red up here. You might have some yellows, which are just warnings. They're not necessarily bad, but there shouldn't be anything that's red. There should be no red underlines. So Once I'm done, let's say I'm done with my program, or I think I am anyway, I come over here and I can close the program because it's already saved to wherever I saved to. So I might want to close it. Then I can go to wherever I saved to, and you can see here, oh, look, cylinder volume's right here. I don't even need to look inside of it. I right click it. I go down to send to compressed folder and press the button. Now you'll notice I have a folder with a zipper, meaning it's compressed. I go over to my portfolio. In Blackboard. See if I get any. And oh, I don't know, pick on somebody here. So I go to my portfolio, file exchange, and I add the file. And I say, what was this one? Oh, cylinder. So I just type in cylinder. I don't type in lesson 2. We treat everything as if you're doing it in real life, not as a student. Okay. And then, so what is the name of the program is? I get browse my computer. Oh, look, there it is, cylinder volume. So I click on it. Oops. Hit open. Whoops, what's going on there? That's weird. Browse my computer. Okay. That's weird. Oh, it's not the zipped one. That's why. You got to find the zipped one. Where's it at? Here it is, the one with the zipper. There you go. And then hit open. And you can see here it says cylinder volume. That's the one I want. I hit submit. And boom, there it is. Okay. Don't put your name in the name of your program. You don't need to. If you're putting it in here, you can see here, I know these are Josh's programs because it's in his portfolio. So he didn't have to put his name here. Okay. If you don't want it in there anymore, you just delete it. Or let's say I want to work on it some more. Say I want to look at Josh's average speed. I right click it. I save it to where I want to save it. Okay, so maybe I want to save it to my desktop. I hit save. Okay, then I can go back to my desktop. Oh, look, there it is. To work on it though with NetBeans, I first have to unzip it, right? So I go over here, extract it. Now it doesn't have a zipper. And if I wanted to, I could open it and change it. Okay. Oops. Of course, I can delete these. All right. So that's how I submit things to my portfolio. That's how I write a program. And it's user friendly, or to the point where I'm user friendly and whatever.
So I've been having the problem where my recent projects, my last 2 projects, didn't get saved in my NetBeans project folder. And I don't know where they're being, where like the file
Well,
location is.
Okay, well, you'd have to go down here and search for them then.
Okay.
Okay, type in the name and then search for them. Or you can open up, okay, here, let's say, when did you see when I here? Let's do this. Okay, so let's say I want to go back and bring up something I did recently. Well, first of all, I can click right here, or I can come over here and say File, Open Recent Project, and there's a list of my recent projects. So if I do this, then I can go over here to File, And I think there's a spot here somewhere. Oh, come on, close file, open recent file. I thought you could get. I was just looking to see. Oh, here, save as. Okay. Cylinder volume. And if you go up, you can see where, like here, I can see that it's in my desktop is where it's saving to. Okay. And you can go back all the way back to your C drive if you want. Okay. But it should be able to find it because, again, NetBeans saves them to wherever. When you start a new program, if I go over here, say new project, I hit this, it tells me right here where I'm saving. So do that. Try and start a new project and see where it's saving to.
Oh, okay. I figured out. So I had a NetBeans project saved to my desktop, and I had another one saved on my documents. So they were like split. They were kind of splitting. Okay. Because I'm like, I thought I was in the folder the whole time, but it's like, okay.
So anyway, that's how you figure out where it's actually saving your stuff to. By default, it's going to save it to documents, NetBeans folder, or NetBeans projects, I should say. Mine, I just have it set up so it's on my desktop so I can readily get to it. So that's that program, okay? So when we come back, so again, I'm trying to get us moving along. So if you have time, you need to also, besides lesson 2, okay, and I'm going to post this video later today. Here's an example of it. I probably shouldn't leave that one in it. Don't watch this one. Watch the one I'm going to give you today, and it'll be underneath lesson 2. In fact, let me go ahead and just not let you see this one. Anymore. All right. So now I'm going to, after class today, I'm going to put a video in here in PowerPoint of what we did in class today. Okay. That being said, you need to take a look at lesson 3. In lesson 3, I introduce you to the second code structure, which is decisions. In other words, if statements. So instead of doing everything sequentially, like we did today, everything goes in order. In other words, I can't calculate volume until I calculate area first. I can't do area until I do pi first. I can't do area or volume until I have a height or a radius. So everything has to be, it runs boom, 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 line after line until it's all done. Now with us moving next lesson into decisions, I can skip stuff, okay, or make a decision. Maybe this program does both circles and rectangles. So it might say if the user picks 1, calculate a circle area. If they pick 2, do a rectangle. Okay. So we'll be able to make decisions. So that makes our programs more powerful. Okay. Again, I'm not trying to put pressure on you, but just start reading over that before Thursday. Or, yeah, Thursday. Okay, I'm going to stop sharing. I thought I was. There we go. So what do you think? Okay. The integer double thing, again, you should know now. Whole numbers up to 2 billion, we're going to stick with integer. Whole numbers up to, or floating point numbers, which are just means fractions, we're going to use double. Now, if you're savvy enough to use the other ones, I don't have a problem with that. Okay. I would stay away from byte. Most of the time, the only time I use byte is when I'm dealing with a program that's running computers. Okay. It's like somebody's age. You can use short, you can use integer. Okay. In fact, you could use long, but don't use byte for somebody's age. Boolean, of course, is true and false. Is the door open? Is the door closed? That's a Boolean. Anything with an equal sign, a less than sign, a more than sign, the answer is going to be Boolean. It has to be, right? Is it equal to? Is it more than? Is it less than? All those come out with an answer of true or false. If you're not going to do math with it, it's a string, okay? If all we're looking for is one character, one character, it's a char for character, C-H-A-R. I think that's it. Okay. But you need to know those. You don't want to have to be looking them up. Okay. You don't want your program like today. If some of you would have used integer for the length and Doug comes along to check it, or the user, worse yet, goes to calculate how much volume they have, and they type in 10.5 and you have an integer, the program crashes. Okay, because an integer can't hold a fraction. All right.